Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They've got top-notch instructors, John Thornton, Scott Schotten, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it. And that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host once again for this week's episode. Thank you so much for joining me. Just me on the show this week, and what I'm going to be talking about this week is bench testing control modules. That is connecting to the module on the bench away from the car. How to do it, why it's useful, and where it has saved me from making a bad call, or at least pointing me in the right direction so I can make the correct call. So I do this frequently throughout the mobile diagnostics, module programming, module cloning, and honestly, the module cloning and programming part of this is where I sort of develop the skill to be able to connect to a module on the bench, communicate with it, and maybe even run certain functions. But really the powering a module up and getting it to turn on, getting it to communicate, and then again, maybe do something, that actually becomes helpful to know how to do if you're going to get to the point of actually condemning a control module or deciding the problems on the car, right? It splits the direction that you're going to go. It eliminates half of the problem so that you can go after the right thing. And sometimes we need that. Sometimes that actually is really helpful. And where this comes from is I was doing a class this last week for a group in Australia, a webinar, and it's called How to Condemn a Control Module. And I presented that class a few times, but it goes through exactly that. Like, what are all the steps in order to successfully say the problem's in the module, it needs to be replaced, or the problem is on the car, right? Circuit, input, output, communication networks, power, ground, wake up, whatever. Right? What is the problem on the car? Or no, the module's failed, it needs to be replaced. So that's where this comes from, and it is part of my test procedure in some cases. Now, you don't always need to do this. Sometimes it's very clear and very simple that, hey, I have everything for this module to operate. It is not operating. It needs to be replaced. Okay. Sometimes there's visible damage to the module, which you're still taking it out, maybe and taking it out of the case. But you don't need to bench test it in that case. But modules are complex. They're nuanced. There's lots of variation to the modules, to the circuits, to the problems that they can have. And sometimes it is more difficult to say that, hey, this module is not doing the thing it's supposed to do, and it's definitely the module, or it could be an individual circuit on the car that is causing it, or something else on the car that is causing this to happen. And one example that pops up into my head is there was a Cadillac that I did a case study on the show on a few years back. It was a parasitic draw. BCM was waking up and talking on the low-speed bus. And it was very difficult to say that it was either the BCM or it was a circuit. And what I ended up doing was kind of separating the BCM from the car in a way, and then adding circuits in one at a time until, oh, okay, this caused the BCM to wake up when I add in this circuit. And that one I kind of did by connector. So I would unplug one connector at a time. So there's variations of this that you could take, but had I fully removed that control module, powered it up on the bench, which is kind of what I did, it would not have woke up. It would not have talked on the low speed bus. But there was a circuit that went to one of the cornering light assemblies that had been replaced with an aftermarket unit, and the bulb outage circuit was pulling a bias voltage down to ground periodically, and that was waking up the bus on this one. And that was tough to find. That was, going circuit by circuit. But in a case like that, being able to at least eliminate the control module as the source of the problem is actually kind of big, right? Now, yeah, you could chuck a part at it, but we all know sometimes these modules are hard to get. Maybe they're expensive. You don't want to be spending the customer's money on something that doesn't need, because just to try a module, you've got to program and set it up to the car. So we want to make the right call before we're chucking parts at the thing. And if nothing else, this gives you some confidence as well to say, like, hey, I've got it out of the car and I see the same problem that I expected, right? That this module is failed. It's also failed on the bench. Okay, so it's not something to do with the car. Or, this module wakes up and talks when it's not supposed to. Still does that on the bench, right? And there's a lot of different problems that you can identify. Some are going to be tough to do on the bench, right? Obviously, modules exist on a network in most cases. They rely on a lot of other circuits to actually run the functions that they need to. Some of these functions are going to be difficult to mimic on a bench, not impossible. You can get creative and you can be the input, you can be the output in a lot of cases. But this is a useful test method, and here's the thing. If you actually take the time to do this, and maybe you do module programming, cloning bench work already, and you might be familiar with hooking up to a module on the bench, but if you're not doing this, actually going through it and connecting to a module on a bench will help your diagnostic skills when you are in the car, right? So when you're actually doing the diagnostic in the car, you're like, what does this module need to function? You're going to be better at that if you've taken the time to actually set up a module on the bench and talk to it that way. So I've found it has actually increased my diagnostic skills, even if I'm not using the method on every single car. Okay, so we've got the module out on the bench, and this is kind of the bulk of the episode here. I just want to give you some tips and some advice as far as getting set up, what tools you're going to need, and what obstacles you might run up against. Okay, so number one, you're going to need something to connect to the module. And then in most cases, you're going to be connecting your scan tool to the module and talking to it directly on the bench. Now, there are some obstacles, there are some hurdles, but what you're going to want to get is some sort of bench test harness. Now, I'll put a link in the show notes. Auto Rescue Tools has a really simple but effective bench harness. It is literally just a OBD2 plug, and then it has a bunch of wires going off of it with pins at the end, female pins of various sizes that link to the pins on the OBD2 port, right? So power, ground, communication, pin one, there's single line communication, there's CAN communication. You have all 16 pins, okay? And they're gonna be connected to these wires with various pin sizes. There's also some switches to turn on and off power, and then there is a female plug that you can plug in a power source, and some banana jacks, so you can plug in power sources that way or add on leads to it if you need to. So it's very versatile. You can connect to most modules using just this bench harness. It comes with a couple terminating resistors. We'll touch on that, but it's the most effective and very reasonable cost. And we have one of these in the shop. We have one in every van. And you can use it for module programming as well. Like you want to do the actual module programming on the bench with whatever programming software you have. Now, those often will have their own harness to connect to it, but you could use this as well. But there's nothing in between the OBD2 port and the actual connections on the module. There is some other breakout boxes like the Go Diag that you can use, but I've been told by people that the LEDs that are in the actual like breakout box portion of the GoDiag. This episode is brought to you by AutoRescueTools.com and Isaac Rodell. If you are looking to get into module programming, but you are not sure what kind of laptop you're going to need or how to set it up for programming, Isaac is your guy. He can set up laptops specifically to do control module programming for specific brands with partitioned hard drives and all the software that you're going to need to do this. He also sells key cutting equipment, scan tools, and other diagnostic equipment. I bought some stuff from him in the past, and the support is phenomenal. So I highly recommend checking out the website. Again, that's AutoRescueTools.com. The link will be in the show notes. Can affect programming. So if you just want to talk to something on the bench, I think it's an effective tool. But I'd be more careful about programming something on the bench using the GoDiag. Anyways, a couple different tools there. I'll put the link in the show notes to the Auto Rescue one. Now, you're going to need a diagram and a pinout in order to find the connections to the module you need. Now, of course, there's going to be power, there's going to be ground, most likely communication of some sort. And then there's also going to be a wake up in some cases, like an ignition wake up of some sort. Now, this does get a little tricky sometimes. Sometimes it's a separate circuit that is just, ignition wake up. It's a switched feed, and you'll have to find that on your diagram. Sometimes that happens through the communication lines themselves. And if this is the case, where the module needs a message from another module in order to wake up and start talking, this is probably the biggest hurdle to actually communicating with a module on a bench. I'll give you some ways you might be able to get around this, but this is a situation where there's a possibility you may not be able to communicate with it on a bench if it needs a specific wake up message. And typically what I have found, this is over like a body network of some sort. But you'll see these where you're looking at the diagram for the module. It's got a constant power, a constant ground, and then like 2 CAN lines, and that's it. As far as like being woken up, there's no individual ignition feed. Now, there are some modules where if you boot them up and then you try to talk to it immediately with the scan tool, it will communicate. And sometimes you have to be a little creative with that and catch it, because a lot of these modules, even if they are meant to receive a specific wake up on the CAN, if you first boot them up, right, you just give it power and ground, it'll wake up and be like, hey, who's there? I just woke up. And then it'll quickly go back to sleep and not talk until it gets the correct message. So that can definitely happen. But what I like to do is in a situation like that is I will take my scope and I will actually put it onto the network pins, whatever that form takes for that module, and then I will remove and connect power or ground to boot the thing up, and I'll watch and see, does this thing shoot out a few messages onto the CAN network or not? And if it does, what I'll do is I'll try to catch it, and you have to time it right, but you're doing the connect to module in your scan tool like right as you're booting that thing up. And sometimes you can catch it, and then a lot of times once you maintain or like begin that communication, it will stay awake and continue talking. So again, that's a hurdle, but you can look at to see if, hey, is there anything coming out of the network lines once I boot this up. The other things you can do here, actually on that note, the other thing I found works on some, not all, is if you take a powered up test light and you touch it to the network pins on the module, it may actually wake up and start talking from that too, because it sees at least something on that bus and it's like, hey, somebody's talking, what's going on? And you can catch it that way. Again, doesn't work for everything. There are modules I found that just won't talk on the bench. You have to have them in the car. You have to have that wake up signal, from that module. Whoever's the power mode master in the vehicle needs to be on that network as well. So there is a limitation there that I want to point out. But lots and lots and lots of modules you can talk, especially the ones that use a dedicated ignition wake up, like 12 volt feed. If you got that, you're probably going to be able to talk to this on the bench. Okay. Now, you also will want to pay attention to what network does that module talk to or talk on normally, and how does that link up to the OBD2 port in the car, right? Because your scan tool is going to be connected to the OBD2 port in the car. And as far as it's aware on the bench, it's still connected to the OBD2 port on the car. So the module you are trying to talk to, does it exist on the network that goes to the OBD2 port? Is there a gateway? Is there some sort of restriction between the scan tool and the module that you're trying to talk to? Does that module normally talk to the scan tool? Of course, that would be an obvious question to ask, but there are modules that are on proprietary CAN networks that don't directly talk to your scan tool. You get the information through another module. Or maybe it's just, it is a network, but it does not normally connect to the scan tool. It gets translated through another module that's on that network. What I have found is if it's connected directly to the OBD2 port, you're going to use your diagram and figure out, okay, well, what pin do I need to connect to the network wire, and then connect it up that way. But if it's a high-speed CAN, it will usually work, even if you have a gateway module. So Chrysler, for instance, if you have an actual secure gateway module, your scan tool is talking to that, and then it's translating messages from the modules, but you can go straight on to the high-speed CAN and talk to it. It's the same protocol. Now, there are medium speed CANs and body CANs, and you may run into limitations there as well. So the actual communication with the scan tool, there could be an obstacle, but that's what you want to take a look at is the diagram. How does this module normally communicate with the scan tool? What is the pathway, and how am I going to connect to it? Now, beyond that, like I said, you can scope and just see, is there traffic coming out of whatever network line is on that module? And that's a really good sign that, hey, that module's waking up and talking. Another really simple thing that you can do, that you probably should be doing if you're doing this method, is looking at the amperage the module is taking. Now, you can do this either through the power source that you're using, if it has a measurement for amperage, which a lot of them do. And I'd recommend just get a stable, benchtop power source if you're going to be doing any bench work with modules, because it's nice to be able to dial the voltage and, again, read the amperage that the module's taking. But you can just use a little inductive amp clamp. If you're using the Go Diag, it has an ammeter built in so you can see. But this tells you a couple things. Is the module turning on at all, right? Now, if you have the wrong connections, right, you put those wires in the incorrect spot on the module, well, number one, you could potentially cause some damage. So do pay attention to the pinout as you're connecting these to the module. But this can kind of prove, if you've got them in the right spot, that this module really is dead. It is not waking up at all, right? There's no current draw from this thing. That's a bad sign for a module when you first hook up power and ground. Usually what I see, modules are going to be somewhere in the 200 to 400 milliamp range when they're just on, not running any functions or anything like that, but just on, they're awake, they're ready to do something, they're going to communicate. That 300 milliamps is probably the most common that I see for most modules. There'll be ones that are outside of that range, I'm sure. But if you hook it up and there's zero, there's nothing, it's not drawing any current, or it's just a few milliamps, that's a bad sign for that module. That, again, connections correct, that is pointing to there is something wrong with this module. And that's where I'll double check my pinout. I'll double check my wiring diagram. Am I missing a wake up? Am I missing a power feed or a ground or something that this module needs to actually wake up and communicate? But that can tell you something. That can point to if that module has failed or not. Now, if you do get this thing awake and you want to talk to it with your scan tool, when you're in the scan tool, do be aware that, again, your scan tool is normally going to talk to the whole vehicle, and it's going to get its VIN number from a particular module. That could be a BCM or a PCM, depends on the car. But it might not be the module you're trying to connect to. So you may have to manually build that vehicle within your scan tool, meaning that you are setting up the vehicle yourself and getting to that topology screen and then picking the module specifically that you want to talk to. This most likely will not be the same path that you take when you just do an auto scan. Again, maybe it's the module that the car normally gets the VIN from. Okay, but a lot of times what I do on the bench is manually building the vehicle and then manually selecting the module. Oh, one other note on the CAN bus side of things. If you're connecting to a module and it's using CAN bus, you are going to need to know if that module contains a terminating resistor or not. And in my experience, modules that do contain a terminating resistor within them, ECM is very common to have a terminating resistor. If it has one, you generally don't have to add one on the bench. But if that module talks on CAN and it has no terminating resistor, you are most likely going to have to add one. So how would you do that bench harness that I mentioned? You'll have 2 extra pins because there's 2 CAN high, 2 CAN low, and the female pins are different sizes, so you can connect to different modules. So you take the 2 that you're not using and you put a 120 ohm resistor across there. And most of these kits will come with resistors in them. I think the Go Diag does, and I know the Auto Rescue one does. So you have them right there, and you just are going to connect those. With the Go Diag, you could use the actual ports on the breakout box itself and just connect up resistor. You could even make your own with, banana jack ends and connect it up that way, however you want. But adding that terminating resistor may be necessary for scan tool communication. And again, this is where I'll have my scope out. Like if things just aren't working, I can't talk to it, I'll use my U-scope and I will look to see what is happening on the circuits where I'm expecting network activity. What does it look like? And you can tell if a CAN network has no terminating resistance. It's like this repeating ringing pattern where it kind of ramps up, drops off, ramps up, drops off, happens really fast and just keeps repeating itself over and over again. Doesn't look like a regular like square wave CAN waveform that you would expect to see. But you add in that 120 and then it looks great. And you don't need the full 60 in my experience. Just one resistor is fine. And then the scan tool is able to communicate. So something to keep in mind. If you're dealing with a single wire network, bear in mind that certain modules are the master of those networks and needed to provide like a bias voltage. Right, so like you won't be doing a LIN bus, but something similar to a LIN bus, there may need to be, a master of that network that is present, and there's a potential that your scan tool may provide what's needed there, but there are situations where it won't. So again, when you get into the single wire network stuff, you may run into some challenges there as well, but use a scope, see what you got going on there. And then again, you can always fall back to, scoping the network, but then looking at the amount of amperage that module is drawing on the bench and saying, oh, and this would be the case of a completely dead module in the car, right? But if it's turning on, it's doing something, okay, I have to reconsider. Do I need to look at the car? Now, as far as running specific functions, right? Inputs, outputs, things like that. You can look at your diagram, find the pin, and then see, okay, can I run, that specific function, out of the car? I don't find myself doing this quite as often with this test, but every once in a while, I want to make sure, hey, it either can or can't do this particular function, and then I'll set something up to either simulate an input or simulate an output, and then see if I can run that function on that module. And it's again just about finding the pins on the module, connecting to it, and simulating something that would be in the car. But that is where I'm going to wrap this one up today. A little bit shorter, but I think this is a useful test method in certain situations. And again, at the very least, it will increase your diagnostic capability when you are trying to determine in the car, what does this module need to function? So give it a try if you haven't. Check out the link in the show note if you need one of those bench harnesses. And then feel free to shoot me any questions you got on this stuff, and I'll be happy to try and help out. But with that all out of the way, let's get out there, start fixing the world one car at a time.